Lesson 2.8, Graph linear inequalities in two variables. Linear inequalities in two variables are like linear equations, but with an inequality instead of an equal sign. So to tell whether it's a solution, the order pair is a solution, you need to plug it in. Let's take your inequality, plug in the 0 for the x and the negative 4 for the y, and simplify. And you look, is 8 less than or equal to 6? No, so it's not a solution. Let's try this point. Plug in the negative 3 for the x and the 8 for the y, and simplify. And simplify some more, you get negative 31 is less than 6. Is that true? Yes, it is a solution. The lesson is mainly on graphing linear inequalities. So to graph, it'll look something like that. You have to remember with inequalities about solid lines and dotted lines and shading. Start off by graphing the line as if it was an equal sign. Then worry about whether it's dotted. It's dotted if it's just less than or greater than. Use a solid line if it's equal to, so that's less than or equal to, or greater than and equal to. And then shade. To shade, pick a test point that's not on the line. 0, 0 is wonderful if it's not on the line, because doing math with zeros is very easy. If that point is a solution to the inequality, shade that side of the line. If it's not a solution, shade the other side of the line. So let's try graphing. X is greater than or equal to negative 4. Start by graphing the line x equals negative 4. That's a vertical line that goes through negative 4. And it's solid because the original inequality is greater than or equal to. And then we need to shade. We need to shade to the right because that's where the x's are bigger than negative 4. And that's our graph. Let's try another. Y is greater than negative 3x. Start by graphing as if it was just y equals negative 3x. If we compare to y equals mx plus b, we can see that the b, the y-intercept, is 0, and the slope is negative 3. So we start at 0, and go follow the slope down 3 and over 1. And our line will be dotted because the inequality is just greater than, it's not equal to. So we had the y-intercept of 0, and we went down 3 and over 1. Now we need to pick a test point. I like 0, 0, but our line goes through 0, 0. So we're going to pick another point, such as 1, 0. Take it and plug that into your inequality. So x is 1 and y is 0. And we end up with y is greater than negative 3. This is true, so we shade the side of the line with our point. Let's try another. If we compare this to y equals mx plus b, we can see that the y-intercept is 3, and our slope is 2, so that's up 2 and over 1. It'll be a solid line because it's less than or equal to For the shading, let's pick a point. Conveniently, 0, 0 is an option. Our line does not go through it. So we'll plug in 0, 0. X is 0, y is 0. Fill it in and you get 0 is less than or equal to 3. That's true. So we will shade the side of the line with the point 0, 0. Alright, let's try another. This one is absolute value. Same process though. Start by graphing y equals 3 absolute value of x minus 1 minus 3. Compare that to y equals a, absolute value of x minus h plus k. And you can see that h is 1, k is negative 3, and a is 3. So because of that, we know our vertex is hk. So our vertex will be 1, negative 3. Right there. And a is the slope of the right side, so we'll go up 3 and over 1. And to get the other side, we'll go the other way, so it's symmetric. Our inequality is just less than, so our line is dotted. Need to pick a test point. 0, 0 is not an option because the line goes through it. So why don't we pick 1, 0? If we test that and plug it in, the 1 is x and the y is 0. We end up with 0 is less than negative 3. That's false. So we'll shade the other side of the line. Now let's try a word problem. You have 2 part-time summer jobs, one that pays $9 an hour and one that pays $12 an hour. $9 an hour is the same thing as saying $9 per hour. And the same thing for the $12 is $12 per hour. The per indicates it's a rate problem. So rate times the amount equals our total. That's how rate problems work. So our rates are $9 per hour and $12 per hour. So we can say 9 times x plus 12 times y. And that would be, we want a total of $240. But we want more than $240. So at least. At least means that amount or more. So that means the 240 is the smallest we'll allow. That's why the 240 is at the small side of the inequality. And again, the 240 is the smallest we want, so the small side of the inequality points at the 240. So let's graph this. So our previous answer was 9x plus 12y is greater than or equal to 240. Let's graph the line. It's in standard form, so we need to find the intercepts. The x-intercept is found by making the y 0 and solving for x. 240 divided by 9 is 26.7 approximately. Find the y-intercept by letting the x equal 0. 240 divided by 12 is 20. So we need to put some scales And I've decided to make the X scale count by 3s and the Y scale count by 2s so that I can fit my intercepts on the scale. Plot my intercepts and draw a line to connect them. Now our line is going to be solid because the inequality is greater than or equal to. Now we need to do the shading. So we need to pick a test point. I would pick 0, 0. So we can plug that in for x and y, and you get 0 is greater than 240, which is false, so we'll shade the other side of the line. Now we need to identify 3 possible solutions of the inequality. Any point in the shaded area or on the line is a possible solution. So you have an infinite number of possible solutions. Just choose 3 random ones. So any 3 points in the shaded area, such as 15, 12, there, 24, 4, which is right there, or 3, 20 are the ones I chose. And that's all for today. Here's your assignment.